All right, colored pens up. So last time we were together, we upped the level of complexity quite a bit. We introduced the idea of having variables on both sides of the equation. That really changes the complexity of the types of equations that we've been studying. So let's see how we're doing so far. And you can also see that today is going to be day 2. So we're going to try and master the idea today by exploring some higher level questions and by looking at them a little bit differently. But let's warm up first. What'd you get for number 1? We'll start with Kiara, Savannah, and then Annie. What'd you get, Kiara?
-7.
Okay.
-7.
So you guys agree?
-7.
Everybody agrees that it's -7. It is -7. Number 2. What did we get? We will start with DeAndre, Cameron, and then Steven.
No solution.
Okay.
No solution.
You guys agree? Okay.
No solution.
Everybody agrees that it's no solution. Number 2 is no solution. Nicely done. Now, real-world application of equations. What did we get for number 3? We'll start with Amani, Adriana, and then David.
7 weeks.
7 weeks.
7 weeks.
You two agree.
11 weeks.
11 weeks. So we have a slight disagreement. Angela, what do you think?
7 weeks.
You think it's 7 weeks. Chelsea?
7 weeks.
So there seems to be more support for the idea of it being 7 weeks. The answer is 7 weeks. Let's start with number 3. And in number 3, the story is this fantastic guy named Juan is trying to save money for a Wii U. And it costs $290. And he's already got $115, and he's going to save $10 each week from his allowance, $15 each week from tutoring. How many weeks will it take? So there's an outline. There's a set list of information that you've been asked to find since your first day of school. What are the pieces of information that I've been asking you to find over and over and over again? Give me the first one, Cameron M. Total. So, what was the total in this question? What was the total? Tatiana?
290.
290. How'd you know that was the total, Tatiana?
Because the Wii U already is 290.
Okay, so it's a goal. We're being told that Juan wants to buy this object that costs $290. So when I say total, I'm talking about the end, the result. It's going to be $290. What's the second piece of information I always ask you to find? Catalina?
Flat fee.
Flat fee, flat number. Also, we started exploring the fact that this could also be thought of as a start number. Not necessarily a flat fee, but a start number. And so, Catalina, what was the flat fee or start number in this one?
150.
And so in this case, very good. And in this case, that is the starting number because he already has that much saved towards his goal. So this is the finish, this is the start. This is the finish, this is the start. Now there's something in between. What's the other piece of information? Annie?
The rate.
The rate. So what is the rate in this case? What is the rate in this scenario? Fancy?
$25 a week.
Okay, I'm going to write down 25 because you said it with such confidence, but I don't see a 25 anywhere in the question. Where'd you get the 25 from?
Because it says that he got $10 each week from his allowance and $15 each week from tutoring, and 10 plus 15 equals 25.
Good. That was a beautiful explanation. We're talking about one person, and it's the same person who's saving from his allowance and making money from tutoring. So regardless of how he makes the money, he is making a total of $25 per week. So that's a level above what we started out studying at the beginning of the year, where you were just given one rate. 1 second, Tristan. So you had to understand that you could combine the two rates into one. You also could have left them separate and written down two rates. You could have written 10 and then 15. There were two rates. There was two ways to think of it. What is the last piece of information that we need to write down so that we can start constructing something? Natalie? What's missing? And what is missing, Natalie? The number of weeks. So we can use an X, an N, a W, whatever you want. So we took this information and we construct an equation. What equation can we construct? Tristan?
25x plus 150.
You said that beautifully. 25, mine was a W, doesn't really matter, plus 115, the starting point, equals the goal, 290. How many steps will it take to solve this equation and find the answer? Stephen?
2.
It's a two-step equation. You should be Yoda of two-step equations at this point. You should be able to use the force to find the answer. You shouldn't have to do much. Okay? It should happen pretty quickly. I'm going to go super fast. Minus 115 from both sides. We're at 25W equals 290 minus 115, that's 190 minus another 15, that's 175. And then divide both sides by 25, and we get W equals 7. And so as long as we set up the equation appropriately and solve it correctly, then we end up with an appropriate solution. And then we can test it out. Then we can say to ourselves, okay, if he makes $10 each week for 7 weeks, that's $70. So this would be 70. And then if he makes $15 each week for 7 weeks, that's 70 and another 35, that's 115. No? Did I do that right? 70 plus 35, no, that's 105, sorry. So that's $105. 70, 105, and 115, will that equal the 290? Does it?
Yes.
Yes, it does. So I'm able to check and prove that I've gotten it correct. Okay? Comments, questions? David and then George.
I saw that the total it was 299 to 15. That's all.
Okay. And you're not the only one. I did this lesson this morning, and I had a few people who had just accidentally wrote the wrong number and actually coincidentally ended up with 11 as well.
Can you move number 2?
Okay, well, let me wrap up number 3, and then we'll talk about number 2. Any other comments, questions on number 3? Good. Make sure you have this down. We're going to be referring back to this later on. And then, so there was a question already on number 2. Give me a thumbs up if you got number 2 correct. A lot of people got it correct. Almost everybody. Good. So I don't need to go over number 2. Looked like just about everybody got it correct. Oh, yes, your question.
When I did it at first, I got but there was no solution after I got 4.5. Is that not a solution?
You got? Well, if you get a solution, that's different than saying no solution. When you say no solution, you are saying that there's no number that can go in place of x and make this a true statement. But now you're saying 0.5 is a solution. So there's 2 different answers. Can't be both. So I would test out 0.5 by putting 0.5 here and seeing if it works. If it works, then that's a solution. If it doesn't work, then it's not. And I can tell you right now, just doing some quick mental math, it does not work.
Yeah, but then I asked doing the
Okay, good. Tristan? Okay, well, I can help you individually. Okay? Good. Any other comments or questions? Good. Yes, Alexis. Sure. Number one, give me a thumbs up if you got it right so I can get some help from some people. Good. Put your thumbs down. Amani, what's the first thing you did? Okay, why did you choose 5n from both sides? Let me just move this out of the way. Good, wow, you said that really well. So if we subtract 5n from both sides, and you put it correctly underneath here, this will disappear. Here is a danger zone right there. That is a -7. -7 equals, and now 9n minus 5n equals 4n plus 21. Did you find your mistake yet? What was it?
I accidentally added subtract.
Good. And that is a mistake that I've seen a lot today. In my class this morning, I had a number of people not doing the inverse. We are always doing the inverse when we are solving an equation. Everything is inverse, okay? Very good. Other comments, questions? Good. Put the warm-up to the side. We're going to come back to it in a few minutes. So today, again, is a continuation of the last lesson. So we're not introducing anything new. The idea is to get even better at these types of equations with variables on both sides. Also, I want to reiterate, or say again, that everything we're studying all goes back to two-step equations. Every equation you've seen for the last week and a half has been a two-step equation that was hidden. And it's your job, based on things that I'm helping you see, is to look for those two-step equations, and then you should be pretty successful. So today we're going to start where we left off. We left off studying just how to solve an equation. We didn't talk about how to apply these types of equations to real-world scenarios. So I did that on purpose. So today we introduced the real-world scenarios. So example 3. We're going to apply the idea to a geometry concept. Find the perimeter of a square. So I'm going to do something different than what I usually do, because this is an extremely high-level, high-functioning group. I'm going to give you 2 minutes. And what I want you to do is, as an individual, I would like you to see if you can solve this problem. Now, it's not a checkpoint. It is an example that we're going to do together. But I want to see what you can figure out on your own, stretching your mind and thinking about what we've done so far. This is not like any question you've seen before, so you're going to have to look and try and pick out things that are familiar, but also pick out what's different. So I'm going to put 2 minutes on the clock, and I want you to work as an individual. It's going to be about 2.5 minutes. Okay, so let's see what we came up with. Give me a thumbs up if you actually got a solution to the problem. Okay, we got a lot of people, so let's go around and see if anyone actually got the solution. All right, Adriana, what'd you get?
I got
5. Okay. What'd you get? You got a solution of 5. Annie?
Okay, x equals 5, but the perimeter is 70.
Okay. So you got 5 and 5, 5. Okay. And there's a lot of people with thumbs up, and now I lost track. Okay. What was yours?
For x, I got 5, and for the perimeter, I got 140.
Okay. George, and then Annabelle?
For x, I got 5.
Okay. -3. Okay. Amani, and then Deandra?
For x, I got 5, but the perimeter is 70.
Okay. Deandra?
For x is 5, the perimeter is 140.
Okay. Catalina, and then Steven?
I got x equals 5, so the perimeter 280.
Okay. Steven?
X equals 5
Okay, so now I'm going to give you another minute and a half, and what you're going to do is you're going to discuss with the people next to you or behind you, only directly behind you or diagonal. So you can't move and you can't go anywhere, and you're not talking across columns, so you're going to have to find 1 or 2 people in your general area to discuss with. I didn't tell you, there was a lot of people who said 5. I'm not telling you what the right answer is. Make an argument with somebody near you to convince them that your answer is correct. I will say this. One person in the room said the correct answer. One person in the room said the correct answer. Only one. So you got a minute and a half. So go ahead and discuss.
What about plus 20? I know you got 69, but what about the 20, 15, like 20 and 5? 6 x 15. Yeah. So you can make that we have 10 seconds left. And then how do you do after that? It's done.
Okay, so now let's come back as a whole group, and first let me say a couple of things. One, I'm incredibly impressed with the discussions that were being had. I am impressed and proud of the students in this room. Let's go back. Before that little round of letting you discuss with classmates, I must say that I'm incredibly impressed with the majority of the students in this room with your initial efforts. The result was not what I was expecting, and I'll elaborate in a minute. Now, let me survey based on what just happened. Give me a thumbs up if you are now confidently certain that you know the correct answer to the question. Keeping in mind that the correct answer was said by somebody. So you just have to now be convinced that one of the people was right. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good, put your thumbs down. Almost exactly half the class is now convinced of the answer. So, what answer are you convinced of? Essence, and then Annie, and then Nolly.
That x equals 5 and the perimeter equals 2.
Okay.
X equals 5, the perimeter is 280.
So we seem to be convinced. Nolly?
X equals 5 and the perimeter is 140.
Okay. So we have some confident people. Everybody agrees that x is 5, or at least everyone who's volunteering says x is 5. So we seem to have some agreement there, but then we diverge in opinion. Some people think 280, some people think 140. Maybe you think something totally different. Catalina, Chelsea, George, Tristan, Kiara.
I think the perimeter is 280.
280. And you thought x was 5 as well?
Yeah.
Okay. So you think 140. So there's 3 people who think 280, 2 people who think 140. George, Tristan, Kiara.
5x equals 240. I mean, 140. 5x equals 140. What? 5x? No.
Let me make a suggestion. Stop talking. Hold on, excuse me. Excuse me. I did say that we were doing a good job. Let's make sure we're being respectful. Just because I'm standing on towards this side of the room doesn't mean that side of the room does whatever they want. Go ahead.
I thought 5 equals x and the perimeter 2 equals 8. Let me explain.
Hold on. We're not ready to explain yet. I'm going to get that in a moment, and I will give you your opportunity. Kiara?
5 equals x and the perimeter is 141 squared.
Okay. So we do seem to have agreement on possibilities. First of all, we do seem to have universal support that x is 5. So give me a thumbs up if you agree with that. So there's a lot of people, but there's still some people who don't think. What do you think x is equal to?
I thought like at first I thought x equals 22.
You thought it was 22. Stephen? Because you had said 5 before. Okay, that's what I thought. Okay, and you still think it's -3? Okay, good. Stick by your. That's good. Stick by it. But I will say this: you're correct. At x is 5. That's fantastic. And the fact that most of you were able to figure that out, I am blown away by, because that was a big leap from what we've done in the past to what we're doing now. So let me ask that first. How did you get the 5? What did you set up to get the 5? Catalina, we'll start with you, and then we're going to go to the original person who answered, Adriana.
Okay, so since it's 4 sides and it's perimeter because it's a square, so you add 8x minus 5, and that gets you 16x minus 10 equals 6x plus 40.
Okay, so you knew that since it was a square, this side was equal to the opposite side. And you knew this side was equal to the opposite side. And so then you added them together and put them equal to each other. Because you know that in a square, all sides are the same. So that was pretty great. So you got 16x minus 10 equals 6x plus 40, you said, right?
Yeah.
And then you solved that equation and you got 5. Brilliant.
Instead of adding it up, I just did 8x minus 5 equals 3x plus 20.
Yep, and you actually get the same exact thing. You don't have to add them up. You can do 3x plus 20 equals 8x minus 5, and you will also get x equals 5. They are equivalent equations. They get the same results. So no matter which way you do it, you do get x equals 5. So Tristan wanted an opportunity to explain, because he said x was 5, but he wanted to explain why he thought the perimeter was 280. Why is the perimeter 280?
Let me explain this. So 16 times x, 16 times 5, that's the x equals 5. You get 80, then minus 10, you get 70. Also for the on the left side, so you get 70. Now 70 times 4 equals 280. 40 equals 70 plus 70 plus 70 plus 70 equals 280.
Very good. And so I love his thought process, but there's a humongous flaw. There's a humongous flaw that he didn't realize that makes the other answer the correct answer. Knowledge?
Because when they did that, they had already doubled the amount. So they doubled the answer. The answer, I believe, is 140, but since they had already doubled it in the first step, they got 280.
That's right. So Adriana, I am so sorry. I skipped over you, and that was an accident. So what was your thought process? Oh, I didn't skip over you. You did that, right? But how did you get, what was your answer? Was yours 140 or 280?
140.
You said 140. That's what I thought. And so do you still think it's 140?
Yes.
Yeah, Nolly's explanation was actually perfect. When you do this equation, you are basically saying you already doubled the side. So this right here accounts for this side and this side. So when you say put a 5 here and you get 70, that's actually the combined distance of this and this. So you're right, it is 70,
Oh.
but the 70 is this side plus this side. And then when you plugged it in over here, you get 6 times 5 is 30 plus 40 is 70, but that's for both of these sides. That's for the top and the bottom. So it is 140. Let me explain it a different way. Forget about that. We know that x is 5. Let's just plug the 5 in right here. Guys, follow with me over here. Plug the 5 in right here. 3 times 5 is 15 plus 20 is... So this side is 35, this side is 35, this side is 35, and this side is 35. 35 times 4 is 140. So the perimeter is 140 units.
Yes!
So,
I told you, Molly.
so I must say, DeAndre was the person who said the correct answer the first time, so DeAndre, you should be proud of yourself. But again, I must say that I'm incredibly impressed. This is the first group, I think I'd say in 2 years, where I had so many people who were able to figure out the 5. Because making the jump to understanding that you have to set this side equal to this one is a big jump from the types of equations you're used to, like this one. This is a huge difference, and so I'm incredibly impressed with your ability to take what we've done and apply it to something different. Does anyone have any comments, questions? Fancy?
What Tristan said to get the answer of 280, I did the same thing, but I know how to double it and divide it by 2.
Right, and that's fantastic because you realize what had happened. That's really important. Annie and then Savannah.
Okay. So for I did the equation with the 16x.
Good.
And stuff, right? And then when I multiplied all that by 5, I got 70. So then I thought that each side was 70, and then I multiplied by 4.
Right, and that's what Tristan was explaining as well, and I understand your thought process there. Do you understand now why the 70 was really 2 sides and not one of them?
Yes.
Good.
Are we going to do another question like that?
You're going to do 2 of them for homework. Okay? So we're going to shift gears and we're going to look at something different. But does anyone have any other comments or questions on this one? Good. Again, we're doing extremely well so far. So example 4, everyone write example 4, but do not copy the question. I want you to read the question to yourself. So go ahead and do that. Write example 4, read the question to yourself. Okay, so here is where we explore something from your homework that a lot of people were confused on, and that's why we're going to spend some time on it today. We're actually spend quite a bit of time on this question, not in the way you think, so just bear with me. First, we are going to solve this question, but it's totally different than the questions we've been studying up until today. Let me go back to the warm-up. Here is an example of what we've been studying in my class. And I truly believe that you should at this point be very good at questions like this. And it's because of this right here. These questions follow patterns. They follow patterns. We are almost always finding a total. We're almost always finding a flat fee or a start number. We're almost always finding a rate. So we always have a good idea of what's going on. Now, we're not changing it. We're just adding to our arsenal of knowledge. Now we're going to explore a different type of question. And so sometimes you will see questions like this, and you'll know to do this. And sometimes you're going to see questions like this, and you're going to know to do something slightly different. There's one major detail that makes the two questions different. I actually brought it up a little bit earlier. What is the major difference between the two questions? There's probably a few. Natalie?
There's 2 people.
That's exactly what I was thinking of. Very good. There's 2 people in this situation, whereas the warm-up question, there was 1 person. And that completely changes everything. Go ahead, Ann.
There's also like no total.
And that is the second piece, and I'm really impressed that you caught that. Because in the warm-up question, Juan has a goal. His goal is to buy something for $290. That goal is really our kind of piece of information that we get going with. But now we don't have a goal. Hopefully you read the question. Read the last sentence to yourself again. Read the last sentence to yourself again. I am not asking you how many weeks will it take Mike to achieve his goal. I am asking you how many weeks until they are equal to each other. That's a very different question that I'm asking. And so we don't actually need a total in this case. What we need to do is we need to define Mike, we need to define Molly, and then figure out how to put it together. So, that's what we're going to do. Start out with Mike. As Annie said, there is no total for Mike, so we're going to skip over that. But guess what? Everything else is there. There is the flat fee or the starting number. There is a rate. And then there's the missing piece. What is the flat fee or flat number for Mike? Savannah?
60.
60. That's his starting value. He's starting with $60. What's the rate for Mike? Cameron?
5.
5. He's going to save $5 each week. What is the missing piece for Mike? Stephen? The total what? Okay, and here's where it does get a little more confusing. What is it that we're looking for? It's a little bit harder to find now. Kiara? We're still actually trying to find a number of weeks. It's just a little bit different than during the warm-up, because we're not going to find the number of weeks till he reaches his goal. We're going to find the number of weeks that he's equal to Molly. So we are still missing the number of weeks. It's just a little bit different. Now let's take a look at Molly. Molly also has the same pieces of information. The flat fee or the flat number, the rate, and a missing piece of information that we need. What is Molly's flat fee or flat number? Alexis? 45. She's starting with $45. And what's Molly's rate? Angela? $8. And what is Molly? What's the missing piece of information for Molly? Essence? The number of weeks. Excuse me. Okay, I apologize. So the missing piece for Molly is the number of weeks. So now we've defined Mike and defined Molly, or at least we've picked out the information. Now we can take the information and write an expression that represents Mike, and then we're going to write an expression that represents Molly. So let's start with Mike. Let's see who can put it together all at one step. What's the expression for Mike? No.
Mike is 60 plus 5x.
Very good. 60 plus 5 times whatever variable, and I chose a W. So that expression defines Mike. Now we need to define Molly. So who can put it all together and define Molly? And even if you couldn't, if you look at what Nolly did, you might be able to figure it out. We've got a lot of people. David?
45 plus 8W.
Very good. 45 plus 8W now defines Molly. Here is what the question is asking. How many weeks till they save the same amount? Another way to say that is until they're equal. So here is what is really being asked. So now we have an equation with variables on both sides, and we know how to solve that. We're experts. Yes, Natalie, you had a comment? Or go ahead. Very good. So now we have the knowledge and skill to be very successful with equations like this. Natalie started us off. We can go ahead and subtract 5W from both sides. And this will disappear, and we're left with 60 equals 45 plus 3W. How many steps do we have left in this case? How many steps do we have left, Catalina?
2.
2. It's a 2-step equation. You already finished it, Catalina?
Yeah.
Good. What'd you do next?
I subtracted 45 by both sides.
Very good. Subtract 45 from both sides. This disappears, and we get 3W equals 15. And my high-level students don't even need to do the last step. You can just say to yourselves, 3 times what number is 15, and what do you get? Cameron?
5.
You get 5. So you don't even need to do that last step. You can just figure out that W is going to be 5, which means that after 5 weeks, they will have the same amount of money. Let's see what happens. Let's test it. Mike has $60. He's going to save $5 a week for 5 weeks. So that's 5 times 5 is 25 plus 60. That means Mike's got $85. Let's see what happens with Molly. Molly's got $45. She's going to save $8 for 5 weeks. That's $40 plus 45. That's $85. So after 5 weeks, they will have the same exact amount. Okay? Yes, yes, and then over there.
I think this is like so much more like efficient than doing what we would have done in elementary school. We took 60 and 45 and just kept adding the 5 to the 8 until we got the same number.
That's right, and I'm really glad you said it the way you said it. Efficient. We could do it that elementary school way. There's students who will do it that way. I mean, you guys are high-level math class. You got to understand that there's students out there who are not blessed with your abilities. And so if you're not blessed with your higher level ability, then what would you do? It's hard for students to understand algebra. And so they resort to more elementary school tactics. Okay, I know he's going to save $5 each week. let me keep doing 60 plus 5 plus another 5 plus another 5, and then see what happens. It's all about efficiency. When you go to college and you're trying to do much higher level math, it's all about efficiency because you don't want to be spending half an hour adding 60 plus 5 over and over again because you have to finish it to move on to the next level of question or the next step. That's the whole point, okay? So I love the way you described your thought, okay? There's a couple of other people, George and then somebody over here.
I had a feeling that it was going to be 5. So like when I wrote them on this paper, I did 5 times 5 equals 16. I mean, yeah, then 85.
Mm-hmm.
And then when I did it to the other side, I was like,
Okay, so you knew what the answer was going to be.
yeah.
Good. That won't always happen though. I mean, if I changed the numbers and made them a little higher, a little more complex, it would be harder for you to just discover the numbers. But there's nothing wrong with what you did. You did something high level. I'm sorry, Adrian, did you have a question or okay? Anybody? Any other comments or questions? Good. So now we're going to use this question to do today's activity. So this was notes. So everyone draw a line across your paper. Now we are going to math lib. We are going to take this question and math lib it. So now I'm thinking by a reaction that we never did the math lib activity. I thought, so let me back up because this was supposed to be the second time you were doing this. So if it's not, I apologize. I will try to explain a little bit more in depth. I apologize. I honestly thought this was the second time you were doing this. So there's a game out there, it's a word game called Mad Libs. And it's a little book, a little flip book, and it's got stories in it. But the stories have missing words. And what you do is you sit with a friend or family member, and you have the story in front of you, and underneath each of the blank lines, it tells you the type of word. For example, a noun might be missing. And you ask your friend or family member for a noun, and they'll say bicycle. And you take the word bicycle and you write it into the story. But the story has nothing to do with bicycles, and so when you read it with the word bicycle in it, it sounds silly. Like the story might be about, I don't know, a spy, an international spy. And he's supposed to be driving his super BMW, souped up BMW, and instead it says his souped up bicycle. And so then you would all giggle and laugh, and it's funny. And so what I've done is I've taken that idea, and now we're going to apply it to a math problem. And this serves a number of different purposes, okay? So here's what you're going to do. You are now going to copy everything you see here. And again, I apologize that it's a little bit faint, so you're going to do the best that you can. And you must write the blank lines just like I have the blank lines here. So I'm going to give you about 2 minutes to copy this down. It doesn't have to be perfect handwriting, but you do need to have all of the words. So take about 2 minutes to copy this down. you're done or not, it's okay. You guys can go back to your seats. Don't worry, your classmates will help you fill in. So for this time only, I am going to break the activity down into 2 steps. Okay? So, but first I need to get you into your groups. This is a group concept, a group activity. So let's have DeAndre trade desks with Annabelle, please. Pick up all your stuff. Annabelle, go over there. DeAndre, go all the way over there. Cameron and Essence, switch seats, please. Yep, Cameron and Essence, switch seats, please. Adriana and David, switch seats, please.
Oh goodness.
George, if you would switch to that last seat. Now, everybody watch carefully. This group up here in the front is going to demonstrate, and then you are all going to do it afterwards. So Catalina, Adriana, you are going to turn your desks so that they're facing each other. Tatiana and Chelsea, you're going to turn your desks that you're facing each other. And then you're also going to slide your desks next to this person and this person so that you are forming one large table. Okay? So now, we've got 1, 2, 3, 4, you're doing the same thing. 1, 2, 3, 4, you're doing the same thing. 1, 2, 3, 4. 1, 2, 3, and 1, 2, 3. Go ahead and do that now. Okay, now, even though your bodies are now turned in a different direction, you need to turn your heads to face up here. So here's what we are doing. We are doing, just like Mad Libs, we're doing Math Libs, you are going to change the story. But we're going to do it in 2 stages. First, you're going to change the story, then you're going to change the numbers. Okay? So I've highlighted the spots that you're going to fill in first. And I'm going to give you 3 minutes to do this part, because this is the easier part, but this is the creative part. You are going to pick 2 new characters. You may not use Mike, you may not use Molly, you may not use Juan, who is my character in the first story. You have to come up with your own characters, and it may be real people's names, it may be fictional characters' names. You can make up your own names. The only rule is it must be appropriate. If it's inappropriate, you're going to get yourself kicked out of the activity. You're going to sit on the side by yourself, and you're going to do a stack of worksheets. And next time I do this activity, you will also be excluded from the activity, and you will work by yourself. So no inappropriate language or words or anything. So it's great to be silly and funny and come up with a funny name, but if it's inappropriate, I'm going to be sore with you. Okay? So you have to come up with 2 new characters. Also, you need to come up with a new product that the characters are buying. So in my original story, Mike and Molly were going to buy an HD camcorder. You are going to pick a different product. It can be real or it can be made up. It can be a diamond-encrusted toilet seat is probably my favorite. You may not use that one because someone already came up with that. Or it could be a Corvette. It can be whatever you would like it to be. It can be silly, it can be ordinary, it can be funny, it can be plain. It's up to you as a group. But it must be appropriate. A diamond-encrusted toilet seat is about the edge of my appropriateness level that I can handle. Anything beyond that, I don't think I'd be too thrilled with. Okay? So, that is your job, your first job. Does anyone have any questions so far? So, you're going to discuss with your group. You've got 3 minutes to come up with new characters and a new object. And everybody has to write it down. Everybody writes it down. Next time we're taking it, I'm going to dump the entire thing out.
No, we should do cars.
Mr. Gallant.
Oh, I know. I can watch one second.
So you guys can start thinking about the numbers.
So how is it? Is 50?
30 seconds. All right. Now, you need to pause, whether you are done or not, pause, and now turn your bodies a little bit so that they are facing up here. So, you should have come up with characters and a new product for them to buy. If you didn't finish yet, that's okay, because I'm going to give you 10 more minutes. But the 10 minutes are really devoted to the rest of the word. Here's the rest. I highlighted only the words. Now we're going to change the numbers. So, we are going to add in a number here, 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 and here. 4 numbers. There are some rules. First of all, after you fill in the numbers, you have to solve your own problem. So keep that in mind. The numbers you choose, first of all, may not be any of the numbers that I used. So you may not use 65, 45, and 8. You may not use any number that ends in a 0. Listen carefully, because I don't have this written down. You may not use any number that ends in a 0. And here's the hardest part. When you find the solution to your problem, it must be a whole number. So when you calculate the number of weeks that it's going to take, it must be a whole number of weeks. So if you pick numbers, a number, and a number, and a number, and then you and your teammates figure it out, and it comes out to a decimal, you're going to have to go back to the drawing board and change something so that it comes out to a whole number. So you're going to have to give some thought to the numbers that you choose. Everybody must write down everything, and everyone must solve the problem individually and come to an agreement as a whole group. So if I come over to this group, I should see a problem written out, an equation, and a solution on Stephen's paper, Cameron's paper, and David's paper. And if they're different, that's fine, but then they should be discussing why they got different answers and who's right and who's wrong. Does anyone have any questions? Yeah.
Yeah, what does this have to be a negative number?
That's an excellent question. I'm not going to answer. Let's wait to see what happens, okay? That's a very important question you asked. I hope people were listening. So now you've got 10 minutes to finish everything. When you think you are done, you raise your hand, and I will come to you, and I want to see what you came up with. These questions may be shared with another class and other groups. You've got 10 minutes. No. No numbers may end in 0.
Okay.
And we should now be moving on to on yours. Write the entire question on one side of the card with no lines. You have that paper. Write the entire question on one side of the card with no lines. But when you're done, give it to her. All of this so yours is the answer key, and yours is a card that I can give to another group for them. Good, hold on. Okay, excuse me. We are back as a whole group, so everyone pause your work. Most of the groups are done. There's a couple groups that I'm not sure about, but that's okay. They're going to quickly try and finish up. But everyone else is going to listen carefully. So, a couple of groups already got index cards. They're going to the next level. The rest of you, I'll give your index cards in a moment. But I need to wrap up the activity. So let's share out. So we're going to start with Fancy's going to read her groups, and then Essence is going to read her groups. Fancy, go ahead and read your question. No, she's writing. Fancy, you're reading.
Anthony and Curly are saving money to buy a toy. Curly already has $25 saved and plans on saving an additional $12. Each week, Anthony has $52 saved and plans on saving an additional $3 each week. Write and solve an equation to find how many weeks it takes for both of them to save the same amount.
Good. And that does work out to a whole number. I'm not going to tell you the answer, but I checked their work and it does come out. Essence, would you go ahead and read your group's work?
Okay, Pickle and Banana are saving money to buy
Hold on. Shh.
A 22-inch penny board. If you already saved $32 and plans on saving an additional $4 each week. Renata has saved $24 and plans on saving an additional $8 each week. Write in some.
Right, we know the last line, but that was very good. Excellent job. Anyone else want to share theirs? All right, Chelsea, go ahead and read yours, and then David will read theirs.
Dustin and Leo are saving money to buy.
Oh.
Dustin already has $11 saving an additional $6 each week. Jen has $4 saved and plans on saving an additional $7 each week.
Are these also people from? Wow. Okay, David, go ahead.
Well, David Sutton's backers.
Shh. David, go ahead.
Jim, Bob, and Jim are saving money to Jim, Bob already saved $7 and plans on saving an additional $11 each week. Bob, Jim has $3 saved and plans on saving an additional $13 each week. Blah 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 blah.
Very good. Excellent job. So I want to hear the rest, and we're going to actually have an opportunity next time to share out a little bit more. So, but we did a very good job. So everyone on their paper should have the question that your groups wrote. When I check your work next time, I'm going to be specifically, as I walk around the room, going to be focused on looking at your work for that question. Okay? But now I need everybody up here. You're going to now draw a line across your paper. Your homework for tonight is related to the two questions we spent a lot of time on today. So you're going to do on page 134, numbers 24 to 36 even, and number 44 to 50 even. That's a total of 11 questions. And you are going to have a quiz on 3.1 to 3.3 tomorrow, which you were told about way last week. If all you do is this homework and you don't prepare yourself at all for the quiz, you will not do well on the quiz. You have to refresh your memory and practice a little bit for each section. So I would pick a few of the odd questions in the textbook because the answers are in the back